Hey everybody, today's lesson is on prime factorization and we're just going to jump right on into it. We're going to start off with a couple of definitions to get us going, and we're going to define what prime factorization is and what factor trees are. So prime factorization is simply a number written as a product of its prime factors. Reminder that product means multiplication. So we essentially are going to create a string of multiplication, and we are specifically looking for the prime factors of that number. Ization being kind of more of the action word. So prime factorization, finding the prime factors and multiplying them. Factor trees is how we find prime factorization. We're going to use factor pairs to break a number down to its prime factors. So it's ultimately what we use to kind of find the prime factorization of a number. So let's look at how we do this. So if I come over here, I've got the steps written out for us. And so the steps for finding prime factorization. Step 1 is to split whatever number you are looking at into a factor pair. Once you've done that split, you're going to circle the prime numbers, if there are any. And then step 3 is just keep repeating, splitting those composite numbers until only prime numbers are left. So step 2 and step 3 kind of go together. It's kind of like one of those if this, then that sort of things. If it's a prime number, you circle it. If it's a composite number, you keep splitting it. And then you keep going until you have only prime numbers. And then you're going to write those prime factors, least to greatest, using multiplication and exponents. Now, this exponents part's kind of optional. I like to teach you it with exponents. You're going to do the same thing no matter what, but eventually we're going to get to finding greatest common factor and least common multiple, and we'll be using prime factorizations to find those things, and you can do it with or without exponents. So we're just going to practice it both ways now, with exponents and without. I just want to make sure you guys understand how to do both. So let's take a look at a couple example problems to get us started. So if I show you, let's start with the number 60. Let's find the prime factorization of 60. So step 1 is simply to split this into a factor pair. So a lot of times when I see numbers ending with 0, I like to use 10. So I'm going to split this into 6 times 10. You can write it with or without the multiplication symbol. I like to put that there, especially for you guys as we're beginning to understand this. Now, this is where we're going to check for prime numbers, and hopefully we all agree that 6 and 10 are neither of them are prime, so we're going to go right ahead and split them again. So 6, I'm going to split into 2 times 3. Now, one thing I like to do is I always like to put the smaller number on the left. So in 6 times 10, 6 was the smaller number put on the left, and 2 times 3, 2 is the smaller number, so I put it on the left. You don't have to, it's personal preference, but I actually like it because in the end, that kind of helps me with my least to greatest. Now, as you can see, I went ahead and I circled 2 and 3 because 2 and 3 are both prime numbers, and that's what we're looking for. So kind of circling it is kind of mimicking that's the leaf on my tree. So if I drew kind of the fancier leaves here, which you don't have to do, that's why I would just do circles, and clearly my leaves don't really look like leaves. Anyway, but what we want in the end is our prime factors. So that's how we circle them. That's kind of tells us to stop. And then over here for 10, it would be 2 times 5, which are also both prime. So I'm going to circle them. And then the last step was to write them in order, least to greatest, using multiplication and exponents. What you might want to do to start with is let's just write them least to greatest, no exponents. So that would be 2 times 2 times 3 times 5. Least to greatest using multiplication. And then now I'm going to rewrite this as exponents, which the repeated multiplication of 2 times 2 becomes 2 to the second power, and then times 3 times 5, and we can even put kind of the exponent of 1 on the 3 and 5. We only have 1 3 and 1 5. You don't have to do it that way, but it's good for consistency to write those exponents in all of them. So we would say that the prime factorization of 60 is 2 times 2 times 3 times 5, or 2 to the second power times 3 to the first power times 5 to the first power. That is the prime factorization. Now, how do you know? How could you check that? Well, if we just did a double check, well, what's 2 times 2? Well, that's 4, okay? And then maybe we did 3 times 5, well, that's 15. Hey, 4 times 15 makes 60. Okay, your prime factorization should equal the number that you started with. So, think you're ready to try a problem on your own? Let's take a look. All right, I would like you to try to find the prime factorization of 42. So pause this video now and solve it, and let's see how you do. Okay, so hopefully you've solved this. I'm going to go through. Now again, you may have solved yours differently. Maybe you chose a different first factor pair here, which is actually okay. I haven't said that yet, but no matter how you split this or break it down, you will get the same prime factorization no matter what. So I'm going to start off with 6 times 7. Okay, I also could have used 2 times 21. I could have used 3 times 14. There's all sorts of them. But for this case, I'm just going to do 6 times 7. I'm going to check for prime factors, which 7 is a prime factor, so I circle it. 6 is not, though, so we have to split 6 into 2 times 3, and then 2 is prime and 3 is prime. So our prime factorization for 42 is actually 2 times 3 times 7, or 2 to the first power times 3 to the first power times 7 to the first power. So the exponents for this one was actually pretty simple. I always circle or box my final answers to make sure it's nice and neat. Let's try another one. So the next problem we're going to try is looking at the number 29. All right, so when we go to split this one, and we'll do this one together because I have a little secret about it. So it ends with a 9, so I know it's not going to work for 2, 5, or 10, using kind of those divisibility rules of looking at the end. I might do a real quick check of the sum. 2 plus 9 is 11. So 3 doesn't go into it, which 9 doesn't go into it, and it's also odd, so 4 and 8. So 29, does it have any factor pairs that work? Oh man, no it doesn't. So what's the prime factorization of 29? Oh, 29 is a prime number? Hey, look at that. The prime factorization for 29 is 29 because it's already a prime number. So that's the little trick when you are finding prime factorization of a prime number. Well, you can't really because it's already prime. So that was a little trick. That's why I didn't make you do it on your own, but I wanted to show you anytime you are given a prime number, it's not going to have factor pairs. That's the definition of prime number. It only has 2 factors, 1 and 29. So it's actually its own prime factorization. Try to remember that from the future. And then now you do get to solve another one, and you can solve this one. Pause the video now. Please find the prime factorization of 100. Right, so depending on how you wanted to split this one, I would maybe start with 10 times 10. Neither of those are prime. So split them into 2 times 5 and 2 times 5, which means, since 2's and 5's are prime, that my prime factorization is 2 times 2 times 5 times 5. Very important that we're getting that least to greatest. Or 2 to the second power times 5 to the second power. It's done that quickly. Hopefully you got the same answer as me. All right, now for the last little bit, we're actually going to do these next couple problems a little bit differently. And I didn't have them typed out ahead of time. But I'm going to give you something like this. I'm going to give you 2 to the third power times 3 times 5. Okay? And then I want you to tell me, okay, what number is this? This is a prime factorization, noticing that it's all prime factors. So you tell me, what number is that the prime factorization of? So you're essentially doing the opposite of what we were doing before, where before we were breaking it down and splitting it into factor pairs. Now we want to reverse those splits and get everything back together. So how would we do that? Well, it might help you, depending on how you like to solve this, to write that out in kind of the expanded form. So using this instead of exponents. You don't have to do it this way, but some might. And if we do 2 times 2 times 2, we find that's 8. And then 3 times 5 is 15. And 8 times 15, well, I know 8 times 10 is 80. And 8 times 5 is 40. So I put those together. Hey, that's 120. So what is 2 to the third times 3 to the first times 5 to the first? Or what number is that a prime factorization of? That's the prime factorization of 120. All right, last problem. Your turn to give it a try. So let's take a look at, I'm going to do the same sort of thing. Please tell me what number is represented by the prime factorization of 2 to the first times 5 to the second times 7 to the first. Solve it out and tell me what it is. So if I was solving this one, I would solve this as 2 times 25, not times 10. Okay, make sure you remember how to do those exponents there. That's not 2 times 5, it's actually 5 times 5. And then I might do, well, 2 times 25 is 50, and then I need to do 50 times 7. Well, if I use some kind of distributor here, 7 times 5 is 35. Add my 0. Hey, look at that. That is the prime factorization of 350. Man, that was a big number. All right, nice job, guys. This is it for prime factorization. Hopefully this clarifies what to do. Good luck. Let me know if you have questions.